All right, what's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to take a look very quickly at the fundamental theorem of algebra. Just super basic stuff here. And what does a fundamental theorem of algebra actually get at? And in a nutshell, it just says that the degree tells you the number of roots that the equation or the function is going to have. So when you take a look at that, it's going to be more, can you apply the fundamental theorem of algebra? So, another name for zeros, of course, is x-intercepts. We've talked about that before, as well as roots and solutions. So these are all words that are used interchangeably. Sometimes when you're asked for directions or how to solve certain things, you'll be asked to find the roots, the zeros, the x-intercepts, the solutions. All those means the same thing. Now, when we take a look at this one right here, so let's take a look at this guy. Y equals x to the 6th plus 3x to the 5th minus 5x squared. So the degree on this, of course, is going to be whatever the exponent is. That is the highest exponent. I don't know why it was that color, but okay. Gotta love technology. So that is to the 6th power. So that means the degree is going to be 6. So the highest exponent, whatever that is going to be the degree. Now, one of the things that tells us is that we've got two different types of possible solutions, real and or complex solutions. So whatever those combinations are, they have to add up to 6. Now, here's one of the very most important things about the real and complex solutions. Complex solutions, I want you to put a star by this or make sure you know that they always come in pairs. So when we look at the complex number column, like we could have 0 complex roots, or we could have 2 or 4 or all the way up to 6, because 6 is the degree of the function. So you can only have an even number of complex solutions. Now, together, the real and the complex solutions, they have to have a sum of 6. So if I have 0 complex solutions, that means all 6 of my solutions have to be real. Likewise, if I have 2 complex solutions, then that means 4 of the other solutions are going to be real. And similarly, 2 real solutions will be paired with 4 complex solutions. And of course, if I have all of my solutions are complex, then that means I'm not going to have any real solutions. So that is what that tells us about a graph. Now, as we get into this too a little bit more, let's also take a look at the number of turning points. Now, whatever the degree of the function is, the highest degree, that's going to determine how many turns this polynomial will have. And it's always going to be the degree. So here's a little formula. The degree, when we talk about the degree, remember, that's the highest exponent. So the degree minus 1, that will be the number of turns that our function makes. So when we analyze these couple of things, let's take a look at these first couple real quickly and tear this apart. Now, when I analyze this, I'm like, all right, bro, what's our degree right there? Our degree is 5. So what's 5 minus 1? You're right, that's right. So 5 minus 1, I will have 4 turns. So the number of turning points in this function would be 4. In the next function, when we look at example number 5, I take a look at the highest degree there, which is 4. So that means the number of turns, so 4 minus 1, the number of turns would be 3. I think you get the idea with it. So go and figure out the number of turns for number 6, all on your own. All right, how'd you do on that one? That one you should have gotten 2 turns for that. So whatever the degree is, it's always subtract 1, and that will give you the number of turns. Now, when we talk about the roots, let's take a look at this. Now, the degree is also going to tell you the number of roots there are. So if we've got 5 roots, because our degree is 5th, that means we could have 5 real solutions. Now, if I've got 5 real, if all of them are real, that means I'm not going to have 0 complex solutions. Now, I can't just go right down to 4, because notice, remember, complex numbers come in pairs. So 4, I would have to have a pair, and the smallest pair number is 2, and 4 plus 2 does not add up to my degree, which is 5. So I can't have 4 real solutions. So that's one of these little things. You can't just kind of go down the line and say, okay, let me just write, 5, 4, 3, 2, 1. So that doesn't work. So you have to be real mindful of that. Now, since they do come in pairs, let's kind of think about that. 2 plus what gives you 5? That's right, 3. So we could have 3 reals and 2 complex. Or we could have 4 complex, but 4 plus 1 gives us what? Yeah, that's right, 5. So my real and complex solutions must have a sum of however many roots, 0 solutions there are for the function. Let's take a look at number 5, then I'll set you loose on number 6 on your own. So with this one, we've got the degree here is 4. So we're going to have 4 roots, zeros, or solutions, which means we could have 4 real and 0 complex. Now remember, the complex next one's going to go up as 2. So if I have 2 complex, that means I'm going to have 2 real plus 2 plus 2. That's going to have a sum of 4. And I could also have 4 complex solutions, which means I would have 0 real solutions. Because remember, that pair, the number of real and complex, must add up to the degree. And the tricky thing is recognizing that the complex solutions will always be even numbers. So that's one thing on there. So go ahead and hit pause, try number 6 on your own, and let's bust this out. All right there, awesome sauce. How'd you do with this one? Hopefully you came up with 3 real, 0 complex, or 1 real and 2 complex. And that's all there is to this one. So you got this fundamental theorem of algebra. That's all you're going to do is look for the number of turning points in the degree of the function, and that's what we're going to do. So next up is going to be the rational root or 0 theorem. So be sure to tune in for that one, and I'll catch up with you guys later. Make it a great day, because there's simply no good reason not to. Peace out.